Bill Gates, How to Avoid a Climate Disaster, the Solutions We Have, and the Breakthroughs We Need.
Bill Gates has spent a lot of time listening to people talk about climate change, and he's spent millions of dollars investing in solutions that, at one point or another, have sounded promising. Some of that money has vanished along with the collapse of various projects and startups. Other initiatives are still experimenting with encouraging results. Suffice it to say, he's learned a thing or two about what's at stake, and about the kind of work that still needs to be done if we're going to save our planet. Convinced by the testimonials of experts and his own extensive research, Gates has a bottom line. We need to get to zero emissions by 2050. He knows this is a big ask. We've gotten used to doing things a certain way, and it's going to take some difficult changes in order to reach this important goal. Ultimately, it's something we must do, and with the right kind of innovation and cooperation, we can get there.
Before we begin, we publish new content every week, so be sure to subscribe to our channel and ring the bell to get notified about the latest extracts. Our videos can be a bit longer sometimes because we never compromise on the content of the book and video. Therefore, it's important to watch the video till the end. Let's get started.
When Bill Gates and Paul Allen founded Microsoft in 1975, they were living in Albuquerque, New Mexico. Back then, the city was already pretty hot. Temperatures climbed to over 90 degrees Fahrenheit, an average of 36 days a year. But by 2050, that number of days is expected to double. And by the end of the century, it will triple. The health and economic consequences will be profound. The reason for this rapid increase in temperature is that we're currently pumping around 51 billion tons of greenhouse gases into the atmosphere every year. And while efforts are underway to improve the situation, this number isn't going down. In fact, it's only getting bigger.
The key message here is, to bring our planet back from the brink of disaster, we need to get our greenhouse gas emissions to zero.
So, what can we do? Well, to start, we need to understand what greenhouse gases are and how they work. There are many different greenhouse gases, including carbon dioxide, methane, and nitrous oxide. Some are more harmful than others, but carbon dioxide alone accounts for more than 70% of yearly emissions. So, to keep the numbers simple, the collective term greenhouse gases also goes by the more scientific name of carbon dioxide equivalents, and this is the 51 billion tons that we're dealing with. The term greenhouse gases does a pretty good job of describing the problem these gases cause. They let the sun's energy in, but they don't let the resulting heat escape once it's bounced back off the Earth's surface. As a result, the heat is trapped, much like the heat inside a greenhouse. It's the same process that makes the inside of your car hotter than the outside on a sunny summer afternoon. The effect of these greenhouse gases is that the planet has gotten hotter. Since the dawn of the industrial age, the average global temperature has risen 1 degree Celsius. Some areas have even experienced a rise of over 2 degrees. That may not sound like much, but on a global scale, it is. And there are many far-reaching consequences. For example, increased temperatures cause more moisture from the Earth's surface to evaporate into the atmosphere. As a result, there are more droughts around the world, more wildfires, and more flooding in areas already in danger of being consumed by water. Already, 20 to 30% of Bangladesh is underwater on a regular basis. This problem will only get worse and more common around the world. This means more displaced people, as well as fewer habitats for both plants and animals. We need to get to zero emissions because every second we don't, the situation gets worse. Greenhouse gases don't vanish overnight. They stick around for tens of thousands of years. Think of it like a bathtub on the verge of overflowing. Even a small but steady drip will cause the water to start spilling over. Getting to zero won't be easy. harmful emissions are caused by many things that we've come to take for granted. Electricity, heating, transportation, large-scale agriculture, and fundamental construction tools like iron and cement. All of these areas will require serious rethinking if we're to reach the goal. What's more, many areas of the world are just now getting more industrialized. Economies are booming. Overall, this is good news. It means more people are being lifted out of poverty and becoming wealthier. But as these countries begin to take steps toward improving their infrastructure and building thriving cities, they're picking up the same tools of industrialization that have led us to our current climate crisis.
The key message here is getting to zero emissions will be difficult, but it can and must be done.
You might be surprised to learn that in the US, a gallon of oil currently costs around $1, while a gallon of a soft drink is nearly 3 times that, around $2.85. That's right, oil is almost 3 times cheaper than soda. We all know that burning fossil fuels is a significant contributor to harmful emissions. But can we blame anyone for relying on efficient fuels like gasoline and coal, given how cheap and abundant they are? This is another reason we need to take quick action. Global energy demand will only increase in the years to come, and we need to start developing viable options that won't further hasten a climate disaster. For the past couple centuries, we've relied heavily on fossil fuels. It's going to be difficult to change the way we run our cities and make the things we use every day. We're talking about fundamental things, like the way our energy grids operate, the way our clothes and foods are made, and how we heat our homes and offices. This is why the only realistic approach for reaching zero is to aim for net zero emissions. It's highly unlikely that we'll stop burning fossil fuels altogether, but it is possible for us to remove the remaining greenhouse gases we do emit. Currently, the biggest contributors to the climate crisis can be broken down into 5 categories. Making things, such as steel and plastic, accounts for 31% of our 51 billion tons of emissions. Plugging in, or electricity, accounts for 27%. Growing things, like plants and animals for food, accounts for 19%. Getting around, be it cars, planes, or cargo ships, accounts for 16%. And finally, keeping warm and cool, with regard to both ourselves and our things, accounts for 7%. In the next blink, we'll tackle the category that we've already made some progress with: plugging in. Electricity is a good place to start because it affects all the other categories. Right now, 2/3 of the world's electricity is supplied by burning fossil fuels. Getting this ratio down to zero will naturally have a major impact on how we make things, grow things, get around, and so on. Things like factories, agriculture, and cars will all require clean electricity to function.
The key message here is getting electricity to zero will take some major innovations.
Electricity itself is a relatively recent innovation. It wasn't until after the Second World War that the US met a skyrocketing demand by burning fossil fuels. Power plants burned coal, oil, or natural gas, used that heat to boil water, and then used the resulting steam to move turbines that generated electricity. This continues to be the way things are done. Other options like hydroelectric power and nuclear power never proved to be as efficient as fossil fuels. Hydroelectric power requires constructing massive dams and cutting off major waterways. And a few disasters, including those at Chernobyl, Fukushima, and 3 Mile Island, have given nuclear power plants a bad reputation. But while these events still resonate strongly in the public consciousness, the fact remains that relatively few people have died as a result of nuclear energy. especially when compared to the human casualties related to fossil fuels. Innovative advances are making nuclear energy ever safer. So there is hope that, despite the few high-profile disasters in our past, we can continue to use nuclear power plants as a clean energy option. As for wind and solar energy, these only account for around 7% of the world's electricity. But this number is expected to rise. Thanks to financial incentives and government funding, progress has been made in these fields, which has brought their price tags down sharply. But there are still some hurdles to clear. One problem is that wind and solar energies aren't constant. Obviously, these energy sources fluctuate depending on how much sun and wind are available at any given time. So we're left with the issue of what to do with excess energy at some points and a lack of energy at others. We could store surplus energy in batteries, but batteries come with their own set of problems. They're big, expensive, heavy, and hard to transport. Currently, there are no affordable battery options large enough to store energy for an entire city, and battery technology is not expected to make any significant improvements in the near future. Instead, our innovation efforts should be focused on infrastructure. As things stand, power grids are old, outdated, and reliant on fossil fuels. They need to be updated to allow for alternative sources like solar and wind power to travel over large stretches of land. And if we could supplement that energy with nuclear power, we'd be on our way to getting to zero. Let's move on to how we make things, which accounts for about a third of the world's 51 billion tons of greenhouse gas emissions. Things like steel and concrete are being produced in abundance around the world, resulting in great amounts of harmful emissions. And this will only increase as more countries become more prosperous. Between 2000 and 2016, for instance, China used more concrete than the US did during the entire 20th century.
The key message here is producing steel, concrete, and plastic creates greenhouse gas emissions, but there may be a silver lining.
Steel, concrete, and plastic are all around us. It's hard to imagine life without them. Every time we build new cities or expand current ones, it requires massive amounts of these materials. Unfortunately, producing them requires a lot of carbon and heat generated from, you guessed it, burning fossil fuels. Steel, an alloy of iron and carbon, naturally releases some of that carbon while being made. Also, it needs to be heated to incredibly high temperatures that are difficult to create with electricity alone. Right now, heating fossil fuels provides a cheap and easy way to make steel, but it also means that 1 ton of steel generates 1.8 tons of carbon dioxide. Concrete production also uses fossil fuels to cheaply and efficiently generate heat and carbon. In particular, cement, a key component of concrete, requires the burning of limestone, which is made up of calcium plus carbon and oxygen. This all adds up to a grim 1-to-1 ratio. 1 ton of cement roughly equals 1 ton of carbon dioxide emissions. Plastics, which may have the worst reputation, may actually come with a silver lining in the future. All plastics contain carbon. In fact, they're a great place to store carbon. Half of the carbon created when making plastic goes into the plastic itself. And plastic is notoriously bad at decomposing, which means that the carbon won't be going anywhere for a long time. The problem is, we currently get the carbon for plastic by using fossil fuels, which is why making plastic is cheap. But that doesn't have to be the case. When it comes to alternative, affordable ways of creating carbon, there are already some interesting possibilities. One is carbon capture technology. Theoretically, we could capture and use the carbon emissions from a power plant. This technology already exists, but it isn't nearly as cheap and effective as fossil fuels. However, with the right amount of effort and funding, it could be a real alternative source of carbon. With regard to plastic, using captured carbon could turn it into a net negative emission product. We'd be taking away and storing more carbon inside plastic than we'd be releasing. Wouldn't that be something? You may be surprised to learn that our food practices account for more harmful emissions than our transportation practices. But at 19% of the annual 51 billion tons of greenhouse gases, how we grow things comes in third. This shows that harmful emission can come in unexpected ways. For example, you may know that cattle produce a lot of methane, one of the most harmful greenhouse gases in terms of contributing to warming temperatures. But did you know that throwing away food is also a significant contributor? When food rots, it also produces methane, and we throw away lots of food every year, the equivalent of 3.3 billion tons of carbon dioxide, to be exact.
The key message here is we can reduce food industry emissions by living more consciously.
Another hidden cause of food-related emissions is fertilizer. The introduction of synthetic fertilizers in the 1960s and 70s was a game changer. Suddenly, people could grow grains and vegetables in places where it was previously impossible. World hunger took a dive. But this advance came at a cost. First, making the fertilizer requires ammonia, which is usually produced through the burning of natural gas. Second, the fertilizer contains so much nitrogen that it can't all be absorbed by the plants. So it runs off, causes pollution, and escapes into the air. That's not good. Nitrogen is 265 times worse than carbon dioxide when it comes to its global warming effects. As a result, fertilizers account for around 1.3 billion tons of greenhouse gas emissions. Scientists are already at work on creating better, less harmful fertilizers. But there's also the issue of deforestation. While the emissions caused by raising plants and animals account for 70% of the food industry's emissions, the other 30% is caused by cutting down forests in order to make room for cattle, growing food, or fuel. In South America, it's mostly for cattle. In Nigeria, where nearly 60% of forests have been razed over the past few decades, the reason is to create charcoal. In Indonesia, deforestation is the result of a booming palm oil business. When the issue differs from place to place, solutions can be hard to find, which is why we need a coordinated global approach if we've any hope at getting to zero. Governments need to offer incentives for farmers to adopt new practices, but we as consumers can do our part by eating less meat, wasting less food, and supporting businesses that employ clean practices. In terms of cost, we can consider green premiums to understand exactly what needs to change to reduce our emissions. Green premiums essentially highlight the cost differences between current practices and the clean practices that will get us to zero. For example, a ton of concrete currently costs around $125 to make. Using carbon capture technology, that cost would be somewhere between $219 and $300. That means the green premium at its highest is a 140% increase. This difference shows that carbon capture technology needs more funding and research in order to become an economically viable option. Now let's look at the kind of green premiums that stand in the way of clean transportation.
The key message here is sustainable transportation options include clean fuels that come with big prices.
You've already learned that oil is much cheaper than soda. For the record, it's also cheaper than milk and orange juice. But this fact shouldn't dissuade us from finding clean fuel alternatives. Like electricity, transportation is an area where we've made some headway. Consider public transportation in Shenzhen, China. All of the city's 16,000 buses have been electrified. For vehicles that travel short distances, like buses, taxis, or garbage trucks, it's easy to set up charging stations and go fully electric. But we have to be careful. There's still the question of whether the electricity is coming from a power station that's burning fossil fuels or using clean sources like wind or solar. In other situations, like long-haul trucking, it's not so easy. Remember, batteries are heavy. In fact, to produce the same energy as gasoline, your battery would need to be 35 times heavier than the gas. That's a lot of weight to move around. So what works for a bus or a garbage truck doesn't necessarily work for a plane, cargo ship, or long-haul truck. Now let's look at different fuels, specifically advanced biofuels and electrofuels. Advanced biofuels derive their energy from plants that are byproducts of farming practices. One of the big pluses is that they could work as drop-in fuels, which means they could work in today's cars, no changes required. Electrofuels, or hydrocarbon fuels, are also drop-in fuels. These work by capturing carbon dioxide from the atmosphere and using electricity to combine it with the hydrogen in water. This would, of course, require clean electricity. Because it's already expensive to make hydrogen without emitting more carbon, this is the pricier drop-in fuel option. While advanced biofuels cost a little over twice as much as gasoline, with a 106% green premium, electrofuels come with a 237% green premium. Clearly, these are two innovations that need more attention and funding in order to bring their costs down. As people around the world become wealthier, they'll travel more, buy more food, and live in homes equipped with heating and air conditioning. Right now, worldwide, there are 1.6 billion air conditioning units in use. Most of these are in rich countries, not in the hottest places in the world. By 2050, that number is expected to rise to 5 billion. Currently, heating and air conditioning account for 7% of the 51 billion tons of greenhouse gas emissions. But as we can see, that number will likely rise in the near future. Already, in places like Mexico, Brazil, Indonesia, and India, sales for AC units have risen sharply in just the past few years.
The key message here is there are immediate steps we can take to reduce heating and cooling emissions.
Air conditioning is a good example of a fixable problem. One of the biggest issues with AC is that most countries don't set minimum standards for energy efficiency. Of course, people tend to buy cheaper models, which often have very poor efficiency. If policies were updated, the energy demand caused by AC units would drop by 45% by 2050. As for heating, statistics show that furnaces and water heaters are responsible for 1/3 of all the emissions created by the world's buildings. And for the most part, they're running on fossil fuels, so we can't fix this by simply switching over to clean electricity. But there is good news. In many places, it's possible to replace your current gas heaters and furnaces with an electric heat pump. This essentially works like your refrigerator, by pumping warm air outside during the summer and inside during the winter. The bonus is that in the long run, you can save quite a bit of money by installing an electric heat pump. Looking at the average cost of heating an AC in Providence, Rhode Island, you'd cut costs by 22% over a 15-year period. In Houston, Texas, you'd save 27%. As you've gathered, there are a lot of steps standing in our way to zero emissions. But there's also a lot of work to do to adapt and prepare ourselves for the climate change that's already underway. We need to create better early warning systems for impending floods, storm surges, and rising water levels. We also need to start building more energy-efficient homes and updating our infrastructure to accommodate clean energy. If you think all this will cost a lot, you're right, but it will also pay off in big ways. Estimates suggest that investing $1.8 trillion into climate disaster prevention will yield $7 trillion in benefits over a period of just 10 years. That's smart money. But as you may already suspect, it's going to take some government support on an international level.
The key message here is, getting to zero will require changes in government policy and international cooperation.
In places like Germany and Denmark, there have been big advances in wind and solar energy in just the last few years. Thanks to government funding, along with policies and incentives that have helped spark a competitive market for alternative energies, prices have dropped such that the green premiums on these energies are closing in on fossil fuels. Something similar needs to happen for carbon capture, biofuels, and other technologies to help us get to zero emissions by 2050. We also need to establish worldwide minimum standards on emissions, with more and better incentives for businesses that meet those standards, and tax penalties for businesses that don't. As for individual citizens, we need to take action. Write to your elected representatives and demand that resources be put toward improving infrastructure and funding new solutions. If you're a CEO or business leader, be an early adopter of new clean energy technologies and impose your own carbon tax on divisions that don't meet your internal minimum standards. Finally, don't settle for reducing by 2030. If we set these sort of halfway goals, we're bound to get short-sighted and complacent. We need to hit zero by 2050, and if we stay focused, demand action, and put our resources toward the right technologies, we can accomplish this. The key message in these blinks is that we need to get to zero greenhouse gas emissions by 2050. It's not going to be easy, but by focusing on the right solutions, it can be done. There are many positive innovations already in place, such as solar and wind energy, which have become more affordable in recent years. But more efforts need to be made to update our power grids and adapt our infrastructure to clean energy. We also need to put more funding and research into biofuels and carbon capture technologies. Ultimately, we need a global commitment to zero emissions by 2050, with incentives for using and funding new technologies. And here's some actionable advice. Know which questions to ask. There are a lot of numbers and facts to sift through when dealing with new ideas, so here are some questions that cut through the noise and can help you focus on what's important. What percentage of 51 billion tons are we talking about? A European Commission recently announced they're reducing air travel emissions by 17 million tons a year. As a number without context, it sounds like a lot, but if you do the math, you find out that's going to reduce yearly global emissions by just 0.03%. How much power does it take? You'll hear a lot about kilowatts, megawatts, and gigawatts. So here's a tip. A kilowatt can power a house. A megawatt can power a small town. A gigawatt can power a city. A whole country needs 100 to 1,000 gigawatts. How much space does it take? Another confusing term that comes up frequently is power density. This refers to the amount of power you get compared to how much space it requires. It's measured in watts per square meter. Solar has a power density of 5 to 20 watts per square meter, while wind sits at 1 to 2 watts per square meter.
Got feedback? We'd love to hear from you about our content. Just share your thoughts and book recommendations in the comments section, and be sure to subscribe to our channel and ring the bell to get notified about the latest extracts. Thank you and have a great day.